This session will be recorded, and the reason why we're doing that is because for the people that can attend this particular webinar, we would like to post this on our web page, so that people that if you felt it was useful to you, you can go in later and double check what was said, or have people in your facilities look at it at a later date. Anyway, with that being said, let's get going. All right. I put this slide up here, and I look at it because it's one of the things we're all familiar with. We all have a vehicle that we drive and so forth, and coincidentally, it's all, we drive these vehicles that are on four wheels. And this is just kind of a diagram of what it looks, what an auto would look like if its tires were out of alignment. So if you look at this like being the rollers on a dryer, and in the diagram on the left, obviously you don't want to drive your car in that condition, because you're gonna create a lot of wear and tear on your tires, and it's not going to handle right. It's going to be, you'll have a shimmy and you'll be all over the place. In the middle picture, obviously that's still not good. You're gonna accelerate the wear on your front tires, and the auto is not going to handle properly. When you finally get to where all the wheels are aligned in the right plane and are aligned together, the car's going to run fine. It's going to handle fine. So if you use that in the back of your mind, in the same way that you would on a piece of rotary equipment, if you can keep everything in alignment and adjust it properly, you're going to get more mileage, better gas mileage, less wear and tear on your tires, and the vehicle is going to run a lot more efficiently. So with that in mind, let's go on into support roller adjustments. Support roller adjustments. Most rotary equipment is on a slope grade, and the product comes from the feed in and transitions down through the unit and out the discharge end. So this makes it pretty much required that the rollers have to be skewed or adjusted to keep that unit from riding so hard on the thrust roller that it takes it out or causes serious wear issues. Some units that are level and some big kilns that have hydraulic thrust rolls are designed not to have any skew on the roller, but the majority of the equipment out in the field is designed to have to, so you have to adjust the support rollers. Okay, we're going to cover both kilns and dryers in this presentation. So what we define a kiln as is a rotary kiln is defined as a counterflow unit with a direct flame on the inside that is refractory line. So it has refractory brick in it. The flame is shooting up the kiln, the product is feeding down. And that's the typical design of most kilns out there. Now they can be 2-pier or up to 7-pier. A dryer, when we define a dryer and granulators or mixers or any other type of 2-pier rotating piece of equipment are two basic designs. One is that it's commonly parallel flow, and this particular slide on the left side is a direct drive line where basically the gases and the airflow comes in contact with the material. On the right hand side, there's the slide is of a steam tube dryer, which is what we call an indirect type of unit, and the product does not come in contact with the drying or heating gases in there. The steam tubes are used to actually do that function. Okay, so talking about support rollers adjustments. Support roller adjustments are there's a few reasons why you would adjust the rollers. The first one would be that you need to control, and this is the most common one, you need to control the axial thrust of the unit. The unit, because it's on a slope and on an angle, is going to thrust hard against the downhill thrust roller, or the thrust roller towards the outlet end. That's the most common reason. There's times when you have to do alignments on this unit, and so to correct the alignment of the unit, you would make some roller adjustments. Another case might be that you start bottoming your gear in the pinion, and you need to raise the gear out of the pinion. And then there's other mechanical conditions that come up that require you to make moves on the unit, like hot bearings or heavy thrust loads of an individual bearing. But those are the most common types of roller adjustments that you would use. Okay, so support roller adjustment to control axial thrust. Most common reasons for adjusting support rollers on a kiln or a dryer is because you're thrusting too hard. In this photo, you can see that this particular kiln is riding really hard on the thrust roller, and you're starting to get grooving in it. It's a best practice to keep the thrust roller on any thrust roller fairly light. The reason why you want to do that is because if you start wearing down that thrust roller, you're going to lose contact with your gear and pinion. And the whole unit will shift in the direction that roller is wearing, and you lose contact. The other thing that happens is you'll have a large gap on the opposite side, which means if the kiln does move uphill or downhill suddenly and you got a large gap, it builds momentum, and you can have damage to the thrust roller as a result. So try to keep your thrust light on your unit. If you're running on that roller continuously, you will wear it to the point where you lose contact on your gear and pinion. Okay, alignment of the unit. These units are designed, whether they be kiln, dryer, granulator, or whatever, they're designed so that the center line of the drum is lined up with the center line of the roller bases, and the rollers are separated so that the elevational center line is on the slope it needs to be able to maintain all the proper slope and elevations of the unit. Okay, one of the most important things about doing support roller adjustments is that it's important to keep records of what you're doing. So many mistakes happen on adjustments, and issues arise because people don't know where they're at when they adjust their rollers. They're not keeping track of how to skew these things so that they're always parallel to each other. So keeping a record of what to do in this particular case, you know, it tells what each bearing is, and the dates on it, when it was moved in or out, and so forth. And you can keep a kind of a record of where you are on adjusting your units by using a simple form like this. Adjusting the rollers to raise gear from the pinion. One of the things that you want to do, and this is a mistake that's commonly made in the industry, is you only adjust the drive rollers. And if you only adjust the drive rollers, what's going to happen is eventually you're going to change the axis or the slope of the unit, so that it's no longer, for example, if your unit was set in at 7/16 inch per foot, if you just keep raising up one pier, eventually it's going to change that slope. Now all your components aren't going to match. They're not going to be on the same slope. This is a common reason why you see loading up of stop blocks or retainers on tires, is because the slope of the unit or the slope of the rollers isn't per design. When you're moving rollers, it's a simple thing. Let's say in this particular case you wanted to raise the gear up 1/16 of an inch. To raise the gear up out of the pinion 1/16 of an inch, you're going to have to move each roller an eighth of an inch or a quarter total move on each pier to get it to raise at 1/16. So it's this ratio is a little bit more of a rule of thumb, but that's kind of the idea that you're doing. So raise all of your bearings in an eighth inch will result in a 1/16 movement at the gear. Okay, you probably have all seen this particular diagram in one shape or form. It's basically the rule of thumbs that it's been around for decades, and essentially what it means is if the unit is rotating downward or towards you, you put your hands down, thumbs toward each other, and the direction that you want to move the kiln would be the direction that you move in. For example, if you move in on the B bearing or the right hand, you move that bearing in, it's going to take the kiln downwards. Okay, if you want to move the kiln upwards, then you would go in with the left hand. So that's kind of the rule of thumb. And if you look at it, it's kind of like riding a bike. If you want to go to the left, you turn your handlebars to the left. If you want to go to the right, you turn your handlebars to the right. Now on the opposite side, because the unit is rotating away from the roller or up, you place your hands up and your thumbs outward or away from each other, and then the same thing applies. Is if you move all your right hand in towards the D bearing, you're going to take the kiln uphill, and if you move your left hand into the C bearing, you're going to take your kiln downhill. And that's basically the rule of thumbs. Okay, so we're going to talk a little bit about kilns now, because kilns are a little bit different animal than dryers are, but you know, most of the principles of roller adjustment apply, but the bearings are different, and the mass and the weight and the speeds are quite a bit different on kilns versus dryers. But this is a typical kiln style bearing that would be on like Alice Chalmers, Fuller, Trailer, different types of manufacturers. And it's called a sleeve bearing. It has a thrust plate on the end, and basically it's only a 180-degree bearing. The bearing sits at an angle that would make it so that it's lined in the same line between the axis of the roller or the tire. In most cases, that's a 30-degree angle, and this is a typical kiln bearing. Another type of kiln bearing would be a collared, where this particular bearing has a shaft that has a screwed-in collar, and you would have to look inside the housing to determine where the roller position is. And then this is the most common type of support roller situation for dryers, and it's a pillow block style bearing, and this is also on some kilns, but typically the pillow block type bearing is what's used predominantly with dryers. Okay, one of the things that is very helpful when we're talking about doing roller adjustments and maintaining alignment on a piece of equipment is that we make things easier on ourselves rather than harder. And one of the things that I found in the industry that is really helpful is if we stencil number on the bearings, whether it's a kiln or a dryer or anything. It makes it a lot easier to describe what bearing needs work on. For example, if you have a hot bearing on the third pier of a 4-pier kiln, you know, rather than going into the description, it's the downhill bearing on the upturning side of the number 3 pier, essentially what you can say is, okay, it's the number 7 bearing, or number whatever the bearing might be. So this is a much simpler way of keeping track of what you're adjusting, and what it does do, guys, is it does make it a lot easier to keep track of records by doing it with this system. And typically what I like to do is suggest that you put odd numbers on the pinion side, even numbers on the non-pinion side, because that makes it right away it's telling you which side it's turning on. Okay, for a kiln, basically what you're looking at, before you make any moves, one of the things that you want to think about always when you're doing any kind of a moves on a rotary piece of equipment is, what bearing do I move that's going to relieve the load on the bearing and relieve the load on the kiln or the dryer or the unit itself? So what you need to do is you kind of have to determine what loads are taking place. On a kiln, this is relatively easy, because if you have the sleeved roller type bearings that have thrust plates in them, you can sound the end caps and tell which direction they're in. On the ones that have a thrust collar, you can actually inspect inside and look at the direction of thrust or the position of the roller. So what you want to do is make some kind of diagrams. For example, the kiln, in this diagram on the left, the kiln is thrusting really hard on the downhill thrust roller. Okay, you've measured the unit, you've gone around and sounded the end caps, and you've got all the end caps on the 2, 3, and 4 pier are thrusting, are in the downhill position, so it's up against the end cap on the downhill side, which means it's thrusting the kiln uphill. So you have 3 pairs where they're thrusting the kiln uphill. The downhill thrust then is coming, that is on the kiln right now, is coming from the first pier where you have both of those rollers thrusting the kiln downhill. So if you work on that first pier and you go out and you start making, you start skewing those rollers to swap that position, by the time that those rollers swap, your kiln should be off that downhill thrust roller. So that's kind of how you want to work. You're relieving the load on the rollers on the first pier, and you're relieving the load on the kiln. Okay, so preliminary preparations for doing any kind of adjustments. You want to record the position of the kiln on the thrust roller. Is it thrusting downhill or is it thrusting uphill? One of the important things about doing any kind of moves or alignment or something like that is keep track of what's going on with your motor drive amperages. I found over the years that if you have motor drive amperages that fluctuate, usually there's mechanical conditions or load conditions inside the unit that are causing either increases in weight or decreases in the load. So, for example, if you're thrusting really hard on a downhill thrust roller and you've seen your amperages climb over a period of a couple, 2 or 3 weeks, where they're not staying stable, but they are steadily climbing, what an indication is that that particular unit is growing or increasing thrust on that thrust roller. It's time to make a thrust move then. Excuse me. All right, another thing you want to do is, before you make any moves on a kiln roller, is always keep track of your temperatures. Now, you can keep track of the best way to do it is actually take a measurement of the roller shaft on the inside. So if you have an inspection port, put an infrared gun on the roller and keep track of the roller temperatures. Because anytime you make moves, you may increase some temperatures, especially if you have damaged shafts or scoring of any kind. When you try to make a move, you're going to get a little bit of a temperature increase. If if it's just because you got a high thrust load on that individual bearing, as you start relieving that load, you should start to see your temperatures start to decrease. If they start to increase, then you've got something else going on, and you need to take a look at it. On any kind of unit, always make sure that your adjusting screws are ready for use. And what I mean by that, they should be covered and oiled or cleaned so that when you come out there and you got to make a move, you're ready. You don't have to scrape off all the grit and product and so forth to even get at the rollers, because that's taking time to do that. So I recommend that you have a cover on them, and then you put some kind of penetrating oil or something on the screws. Keep those screws in good shape, because if you do get a hot bearing, or you do get a situation where you got to get the kiln or dryer off of the thrust roller in a hurry, you don't want to be messing around with cleaning up screws. So that's a very important thing. If you keep in a logbook, great. Check what the last moves were so that you know that you're keeping a pattern of adjustments, so that you're not just working on one pier or one individual roller. You want to distribute the thrust on all of your rollers, not just one pier or two piers. If you do that, all you're doing is increasing the wear rate on those rollers on that pier, and all the things that come with it. So keep a logbook. If you don't have a logbook now, start using one. Okay, set up your dial indicators on both bearings. And what I like to do on kilns is I like to put them on the back side of the bearings, away from slugging wrenches and activity and things that are going on, because especially if you're making moves for alignment where you got to make a specified amount of moves, if you bump your dial indicator, you don't know where you're at, so you can lose track of what you're doing. So keep those dial indicators out away from things. Used to be a common practice that people would do flats on the screw. So if you turned the adjusting screw one flat, supposedly it was so much movement. The problem with this method is that you really don't know actually what you're getting the movement, because I've seen situations where you turn a screw quite a bit and there's no move, and then the next turn you move, it jumps or makes a big move. So if you don't know, if you're not keeping track of that with a dial indicator, you have no idea of how much you actually moved. On kilns, one of the method, probably the best and safest method of doing any kind of adjustments are to use hydraulic jacks. This makes the job a lot simpler, a lot more effective. You can keep a continuous pressure on it, and you're not dealing with a lot of banging and so forth, things that goes on. So a hydraulic jack is really a good way to do. They are kind of expensive, so not everybody has them. Over the years, we've done all kinds of things. You know, we use change falls, slugging wrenches, sledgehammers, you know, you name it. Put hydraulic porta powers on, pushing the bearings, doing different things, and they all work. They have worked over the years. It's not a very efficient, effective, and I've actually seen a lot of injuries as a result of using heavy sledgehammers, chain falls, and things like that. So that's one thing to keep in mind. And with the way MSHA and OSHA is anymore, they're looking for reasons to nail you. Okay, this is an example of adjusting a unit for alignment. Okay, this particular unit we've done an alignment on this one, and we found that the unit's out of alignment. As you can see, number one is it has a minus sign on it. So what that means is we have to move it out or not in. So it's kind of a negative move, going away from the center line or the axis of the unit. So number one has to go out 91 thousandths. Number three, 12 thousandths. which normally we wouldn't even move that one. But number 4 has to go out quite a bit, 278, and number 2 is moving out 198. There's a difference in movement. There's a difference in these numbers. So what this is telling you, if you look at it, is because number 4 has to go out that much more, about 90 thousandths more than number 2, it means that number 4 is in towards the center line of the base by 90 thousandths. So it's skewed 90 thousand. And typically, and if you look at it, on the number 1 and number 3, the same scenario is number 1 is in about 80 thousand. So the roller is parallel to each other, but it has 90 thousand skew on each of these rollers. So what you want to do is you want to start with the largest move, because if you start to back out number 4, then you're going to actually release some of that skew. So by backing out number 4, what really is happening? Now, if you think about it, if the unit is turning away from number 2 and number 4, if you stand there and look at it and you use your rule of thumb, you place your hands up, and if you want to make the kiln go downhill, you would move number 4 in, correct? Or actually, if you want to move the kiln uphill, you would move number 4 in. So by backing it out, essentially what you're doing is you're bringing the kiln downhill, and that's the direction you want to go. So what you would do in this particular case is you would keep backing out number 4 until it evened out with number 2, or until the kiln came downhill. And then if the kiln came downhill before you got to that, then you may have to go to another pier and make some adjustments so you can continue to make the alignment moves. But you can kind of see that adjusting for alignment on a kiln is you got to really look at where every roller is, how to relieve the kiln thrust, and how to relieve the individual roller thrust. This is an example of that. Okay, when you're making moves on a roller of any kind, I suggest, and it really depends on the make and model and the size of the unit. I've seen some units that you can only move 2-3 thousandths of an inch on your dial indicators, and you'll start heating up a bearing. Those are big, massive iron ore kilns. Whereas most commonly kilns that are used for lime recovery, cement, or lime, or those type of kilns, basically you're going to be able to make a 5 thousandths move without any problem. So use small moves. It's one of the things that we suggest is that you always maintain a balance of your adjustments. So if you go in with one roller or one bearing on a roller, it's best to bring out the other bearing. And if you do that, if you go in 5 on number 4 and out 5 on the number 2, essentially what's happened is you hasn't changed the center of that bearing. You maintain alignment, and that's the reason why you want to do that. This helps maintain alignment. If you keep going positive moves all the time, eventually you're going to change the axis of rotation on the unit. Okay, basically we've already talked about having indicators on both bearings. One of the things that at a plant level, when you make any moves at all, what you want to do is you don't want to get in a hurry. The kiln didn't get, or the kiln or the dryer didn't get in that condition overnight, so don't expect to make all the changes overnight. Start working on it and work with small moves and give them time to adjust and react to the moves that you make. When you're moving number 4, when you're moving the bearings out, one of the things very important, before you finish for the day or let that thing go, make sure that adjustment screw is tight, because the reason why we have both dial indicators and so forth on the bearings is we want to maintain a good controlled situation of adjustment. So if you're backing out a roller and for whatever reason, and when you're done for the day, what you want to do is you want to take that adjustment screw back in just slightly till you see the indicator move. Then you know you're snug up against the bearing. And I've seen this happen in the past where if you leave a gap between the adjustment screw and the bearing housing, then that unit can jump later on, and you don't have a record of it anymore. So always make sure you're snug when you leave and let that unit sit for any time. Okay, on number 5, if you do have hot bearings, the best thing to try to do is cool the bearing down first before you make any moves. So if it's on a kiln, a lot of times what I've had to do when I come in on a hot bearing is I'll try to put some STP in there, or if it's a compatible type lubricant, a mineral-based oil or a synthetic that'll handle it. You can put some STP or something to cool the bearing down before you start making the moves, because if it has scored that shaft, when you make a move, even if you're trying to relieve thrust, if it's scored, you're going to increase the temperatures, and sometimes it's a fine line. So cool the bearing down as best you can, and a lot of times this can be just a fan or just blowing on dryers. You can blow a fan on the thing and get a nice airflow going, and sometimes that'll bring temperatures down. Otherwise, you can circulate the oil in a kiln bearing and bring the temperature down also. Try to get that down before you start making moves, because you can actually get a bearing to heat up on you. Okay, and here again, we always want to make sure that we are doing adjustments that relieve individual thrust on the bearings and individual thrust on the unit itself. Okay, we're going to talk a little bit about two-pier alignment. Most of that stuff that we talked about on the kilns is applicable to dryers as well as kilns. But we'll repeat some of those things. Now, this is basically a diagram of what we do with an alignment. You're trying to maintain an angle that is appropriate. On this particular case, the rollers to the tires are 30 degrees. So you want to maintain that angle, and you want your elevation to remain stable or consistent on all your piers. And if you do that, you'll maintain slope on the unit. So basically what you're going to do on a two-pier unit is very similarly, you're going to record the position of the dryer. Is it thrusting on the downhill? Is it hard on the downhill or uphill? Are the dryer amperages high, low, or whatever? Record them. Make sure that when you start to make moves that you're not increasing amperages, that if anything, you're maintaining the same amperages or decreasing them. Use temperature guns, infrared guns, and take temperatures of your bearings, take temperatures of your thrust roller. Anything that you can do to give you any kind of sign that you're going in the right direction is a very useful thing. Some guys will ask, well, what if we got a fixed bearing? Well, then you're a little bit off on that. But even if you have a fixed bearing and you've got a roller skewed really hard where one of the pillow blocks is actually changing its angle as a result of the skew, you're going to get temperature that will generate in that bearing. So taking temperatures is a very good thing. Here again, we're talking about adjustment screws and so forth. You want to make sure you are able to turn it when you need it and not have to mess around. The other thing I want to talk about is on pillow block bearings, for example. For some reason, people think that they got to really crank down on the tie-down bolts on these pillow block bearings. those tie down bolts are just are there so that they make sure that the unit doesn't really or the bearing doesn't tilt or so forth, and you lose alignment with the bearing in the shaft. You don't have to torque those bolts. In fact, I tell plants just to snug them up hand tight where they're tight, but you can come there and break them loose quickly and without putting cheater bars on and so forth, because that just takes time. And if you've got a hot bearing or a situation where you got to move quickly, that's just slowing you down. And there's not a real technical reason why you need to tighten those that hard. In fact, on that inside bolt, a lot of times where it's hard to get at while the unit is turning, I just basically hand tight that and leave it. I don't even leave it. If you can snug it up so that it's tight, but it's not going to restrict the bearing from moving if you make movements, and then you just don't even mess with that. So you snug that one up and tighten, hand tighten, or with a wrench you tighten up fairly decent the three remaining bearings, and then you don't have to get in there underneath the unit to try to loosen that one up when you need to make moves. Okay, again, I can't emphasize enough that you need to keep a logbook, adjustment logbook. This will keep you out of so much trouble, and you'll be able to maintain your equipment a lot easier if you know what you've been doing in the past, and you can look at it and say, we need to do this. And you can, before you even go out to the unit, you should have a pretty good idea of what you got to do. And then set up dial indicators even on a dryer on a small unit on both bearings, because the same thing is we want to move one in and one out when we're making adjustments, and we want to know exactly what we're moving and not using flats where you don't really know how much you've actually moved. Pillow block bearings are a little difficult to find out where you're at with skew. This is an instrument that IKD came up with to measure how the roller is parallel to the tire. So in this case, if you see this, you got an indicator uphill or higher and lower on the tire. It's a magnetic base that sits on the roller, and you can actually measure how much skew that roller has using this method. The other thing that we do when we're doing adjustments on pillow block style bearings, and even on kiln bearings for that matter, is we will put a dial indicator at the 12 o'clock position on a bearing, and basically if you put a dial indicator right there on the bearing, you can and put like some soap or something across the roller. You can bump the unit, and it'll show when the soap hits through the tire. Basically, then it's going to make a reaction. So if this bearing has got a lot of pressure on it, for example, when that soap hits, it's going to relieve pressure, so you can see the dial indicator move. And basically then you can fine-tune your adjustment after you use an instrument like the T-Track or after an alignment. So there's ways to do pillow blocks to really lighten up the loads on that. Okay, here again we want to use small moves, no more than 5 thousandths per bearing. To maintain our alignment, we want to move in and out. We want indicators on both bearings. We want to make sure our adjustment screws are tight. And there again, if we have a hot bearing, the best thing to do before making any moves at all is try to get some way to cool that bearing down. Especially on hotter units, I would avoid pouring water on it, because that can shock the unit and cause a lot of problems, especially on hotter kilns and so forth. So the best way is to use oils and grease and do whatever you got to do to try to get the temperature down, because usually when you're having a hot bearing, what's happening is you have metal-to-metal contact, which means the lubrication has broke down. and it's not creating an oil film between these metal components, and that's why you're generating heat. So if you can get oil in there or grease or whatever, you have a good chance of cooling the bearing down. Then you can make the adjustments without it being in kind of a precarious situation. And here again, always use the practice of trying to relieve individual thrust loads on pillow block bearings and relieve the loads on the unit itself, the thrust loads on the thrust rollers. Okay, general concerns that we have for misalignment or misadjustment of rollers. One of the biggest things that I've seen over the years is, for whatever reason, maintenance people will pick out a pier and say, this is my favorite pier to adjust. Whenever I make an adjustment on this pier, it responds. And if that's the case, then they run right out there and do that. The problem with doing that is you're going to eventually mess up your alignment. And also what you're going to do is you're going to put a lot more load on those two rollers that you're always adjusting. So the wear rate's going to increase on them, and there's a lot of different load things that can happen if you're using that practice. The best thing to do is use all your rollers equally. And the more you can do that, you will minimize the wear rates on the rollers and the tires, and distribute the load uniformly through the whole unit. That'll take less energy to operate that thing. Your motor drives will be working less, and everything is going to roll a lot more freely. The more you skew, the more friction you have, and the less rolling action you have, so you're going to have wear. Okay, one of the things that I've seen happen over the years too is if in this particular situation with this this tire here, it's thrusting really hard against the downhill retaining band or stop blocks, if you want to call them. What that does is that creates a gap on this other side. So I've seen plant people say, okay, listen, we need to get that off. We're gonna tear up those stop blocks, that retaining band. So we got to get the pressure of that tire off there. So go skew your rollers to push that tire uphill. The problem with doing that is the reason why this is skewing or thrusting hard in this direction is that there's a misalignment happening. You either have a misalignment in the tire, or so the tire's not aligned with the shell, or the shell alignment is not on the right axis, or the roller is not on the right axis. Any one of those combinations will cause that tire to thrust hard in a direction. So by trying to do that with roller adjustments, you're actually creating two misalignments. You have the misalignment of the axis of the tire and the roller to the shell, and now you have over thrusting of rollers. So that's one real common that can tear up rollers real fast. So skewing one pier. So basically, this is kind of an idea. One of the things you don't want to do is get these rollers where they're not parallel with each other. So this roller here, these rollers are skewed, but they're parallel. If you skew rollers so they become what we call pigeon-toed, what you have is now one roller is thrusting the unit uphill and the other roller is thrusting the unit downhill. What that does is that causes basically the tire not to roll freely on those rollers, and you're going to get wear patterns. This is really a common practice on dryers because it's so hard to know where the pillow blocks are on dryers. And if it does, you'll get a lot of vibration with this type of condition, and basically it can cause a lot of damage in a very short period of time if you skew your rollers in that manner. So my final thoughts on this is, okay, we want to keep a record of when we make our moves and follow a designated pattern so that we maintain our alignment and distribute the loads and the thrust of the unit equally between these rollers. I can't stress how important that is. Another thing that you want, another thing that you want to do is always check with your operations or your operators to see what the condition of the unit is. And this would be whether it's a kiln or a dry. There are times when the process is in an upset condition. For example, you know, on kilns you might get ring buildups, you might get coatings, heavy coatings, different things. Even on dryers, I've seen with certain products you can get coatings and so forth. Well, that increases the load significantly on the unit, so your unit is going to thrust differently. So, for example, if you get heavy loads or you get loads in different or fluctuating loads, that can change the way the unit's thrusting. Make sure before you go out there and you start making moves on the unit that you're not in an upset operational condition. So basically, always check with operations to make sure you're at, because what you don't want to do is go make some moves and then everything settles down and you're thrusting in the opposite direction. You got to go back out and make moves to counteract the moves you just made. Practice good housekeeping. Keep those rollers out of product. I see a lot of times where the unit's running in product. The oilers are putting so much grease in there that they're flowing out of the seals and everything. Gets in the products, mixes in the product, and you're running your oils and you're running your rollers in a lapping compound. The other thing that happens with that is if you get oil or grease on the surfaces of the rollers, what's going to happen? The friction is going to decrease, and you're going to change thrust. That unit's going to come downhill hard. And that's why you kind of want to maintain all these things, because if these things happen, you can have a lot of damage occur in a very short period of time. So to keep an eye on your housekeeping. And the other thing to do is make sure that when you're making any moves at all, give that unit time to respond. And one of the practices that I recommend is that when you are going to make some moves on a unit, start on a Monday morning, do moves in the morning, and let it run in the afternoon. If you come in on Tuesday, look at it and say, okay, we still got to make some moves. Make some more moves, and then let it run all day Tuesday. And do that on Wednesday, again, if it needs it, and then stop. Let it go. The last thing we want to do as maintenance guys is when we got a good fishing day, is to get called in and have to come in and adjust rollers because something went goofy on them. So anyway, that's just some suggestions that we have for doing support roller adjustments. And I'll field your questions now. Okay, I see no questions, so I'm just going to open up. All right. Okay. Any questions? Any questions? Hello? Okay, if anybody has any questions, you can raise your hand, and then I'll unmute you, and we can. All right, Andrew Porter. Hello, Andrew. Can you hear me? Andrew, on the STP is a high temperature additive. So basically, what happens is when you put that in there, it automatically gives your oil that you already have in there. It boosts it up and gives you a higher oil film pressure, so that you have an oil film that goes in between the liner and the shaft, and will start bringing your temperature down. Okay, Ken Dorset. We're going to have this presentation, Ken, to answer your question, is we are going to have a copy. We will put a copy of this presentation on our webpage so that you can get in there. Now, if you want to have a hard copy, get a hold of your customer representative in your area and ask her if you could get just a disc with a copy of the presentation. I'm sure we can do that since you attended the webinar. Okay, this is for Kim James. On the slide with the 3 different SKUs on the rollers, the print said that the middle was wrong as well as the bottom. Hang on a second, we'll go back up to that and just take a quick look to make sure, because if that's the case, I don't. Okay, so on this middle one, it says adjusted neutral, that's okay. Adjusted, the middle one is okay, and the one down on the bottom is wrong. Okay, is that the one you're thinking of? So it looks okay to me, to be honest with you. Okay, any more questions? Okay, then that's our webinar for today. Appreciate you all checking in with us. Oh, hold on. Andrew, did you have a question? Okay. Any questions on any of this? Dan, all right. I don't think we got you yet. All right, not sure what they are called, the welded-on blocks that keep the tire and shell torsionally relative to each other. They keep breaking off on your unit. Okay, the reason why that's happening, Dan, is you have a misalignment either of the shell, the tire, or the rollers. It's a lot of times what I found is the rollers are basically from pure settling or so forth, are not on the same slope as the dryer, and in some cases the dryer can be wrong. So basically, I would recommend that you take a look at the alignment on the thing, because it's a high thrust loading of the tire on the retainers is an alignment issue. James LeBlanc. Can you hear me, James? What can I do for you, James? Ryan, where can I access the webinar for reference in the future? It'll be, there again, contact your representative, but I believe we put that on our YouTube or our web page, and you should be able to access that. We can get that information to you.
Hello? Can you hear me now?
It's I just got a clarification. That's on YouTube. So our IKD YouTube is where it's at. And what we're going to do is, any of you who had questions on this thing, in case for whatever reason I missed you or you want to clarify more, we're going to follow up. Andrew Porter, I see your hand up, but I can't hear you. So
This is not on you.
you
Hello?
want to write out your question again, and I'll be glad to answer it.
Hello? Hello?
What's that little red one up top? You still muted yourself?
No, I'm open now. Supposed to be able to hear me. Can you hear me?
Okay. Well, let's basically this is the end of this session. Here again, it'll be on. Andrew, I guess you're talking, but I can't hear you.
Hello? Phone him later.
What do we got?
All right. So, Andrew, could you do this? Could you? I can't hear you for some reason, and
Says people can hear you.
if you could either write it out and you note your question, we can get back to you, or get in contact with your representative. I'll be glad to give you a call.
That's all we got to do.
Okay, then we're going to sign off now. Thanks a lot for attending this webinar.